3, we are going to find some special products of polynomials. These are shortcut patterns, basically. You could definitely work these binomials out by FOILing, like we did in the last section, but who doesn't want to take a shortcut, right? The other reason is that later on in this chapter, when I'm asking you to put it back in this form, you have to know this shortcut. So this section is very important today because it's really going to help you out a lot later on in this chapter. So the first thing we're going to do is I'm actually going to take x plus 4, this example, and I'm going to FOIL it out using that 4 squared that I introduced at the end of the notes last time. Okay, so there's my 4 square. And then it's x plus 4 times x plus 4. And remember, we know this is definitely not x squared plus 4 squared. Remember that from chapter 8? We said that. It's x plus 4 times x plus 4. So an x and a 4 go on each side. We don't need to put the plus sign there because everything's positive, so we just leave it like that. And then what we do is we multiply together the two items that are basically in that column and row. So this first square here is this x and this x. So x times x is x squared. This one is the 4 and the x. 4 times x is 4x. This x and this 4 make 4x. And this 4 and this 4 make 16. So my final answer is x squared plus 8x, those are like terms, plus 16. Now, what can you see about the shortcut here? Did you notice anything of how you got the h compared to what was in here? Basically, I had 2 of those 4x's, didn't I? So if I use the shortcut of 2 times 4 times x, that gives me that middle term. So if I multiply by 2, the first number times the second number, I'm going to get that middle term. So this pattern is a squared. It's the first term, you're just squaring it. And the b squared goes at the end. See, 4 times 4 was 16. And this is a 2ab. So basically you multiply those two terms together and then multiply by 2 to get to the middle term. Multiply those two terms together, 4x, multiply by 2, you get the middle term. That's the shortcut now, so you don't need to FOIL anymore, and you don't need to do the 4 square. So in this case, it's a squared minus 2ab plus b squared, because there's a minus sign in between them. This is called a square of a binomial pattern. We're squaring a binomial, okay? So what is 3x squared? Well, 3 squared is 9, and x times x is x squared. So that's where the 9x squared came from. Over here, what's negative 2 times negative 2? Positive 4. But the first term times the second term is 3x times negative 2, which is negative 6x, and then you multiply it by 2 to get that middle term, which is negative 12x. Okay, so that was a 2 times the first term times the second term. 2 times 3 is 6, times negative 2 is negative 12x. That's where that middle term came from. So that's the shortcut that you're going to be taking each time now when you have a binomial that is being squared. So look down here. Do I have a binomial? Yes. Is it being squared? Yes. So take the shortcut. It's the first term squared plus 2 times the first term times the second term plus the last term squared. So 4x squared is 16x squared plus 2 times 4 is 8 times 3 is 24, and there's an x, and then 3 squared is 9. That's the shortcut. Could you have FOILed that out? Sure. Could you have used the 4 square? Sure. But I want you to learn the shortcut so that your life is easier later on in the chapter. Binomial, minus sign in between, multiply them together. So 3x times negative 5x times 2. So 2 times 3x times negative 5y, sorry. So that becomes, oops, plus a negative. I should have just left it as a minus sign. It's the same thing. It's okay. 2 times 3 is 6 times 5 is 30, and it's an xy. The 9x squared's in front, the 25y squared's in the back. All right, so pause the video, try the checkpoint down below, see if you got the shortcut. Okay, so here we go. Number 1 is x squared plus 18x plus 81. Number 2 is 4x squared. Make sure you did 2 times 2 there. Minus 28x plus 49. And again, make sure you did 5 times 5 is 25r squared plus 10rs, they go in alpha order, plus s squared. All right, let's look at the next page. These are a little bit different. They're also a special pattern. They're called the sum and difference pattern. So what happens is you have two terms that are being multiplied together, two binomials, and they look almost exactly the same, but one is a sum and one is a difference. So what we're going to do is we're going to work that out here in our 4 square and see what happens. So in this case, I'm going to put x plus 4 here, and it's just a positive. It could have gone on the left side too. It doesn't matter where it goes. And this one is x minus 4, so I put a negative 4 there. And now I multiply out the squares. X times x is x squared. 4 times x is 4x. X times negative 4 is negative 4x. And then 4 times negative 4 is negative 16. So what do I have if I write this all out? I have x squared plus 4x minus 4x, or plus a negative, and plus a negative 16. What happens to the two middle terms? They're opposites, so they cancel out, and I'm just left with x squared minus 16. So when you have a sum and difference pattern, it's the first term squared minus the second term squared. So x times x was x squared, 4 times 4 is 16, and it was a minus sign. So that is the shortcut you can take from now on. So what would this one be? It would be a squared minus b squared. The middle terms cancel out. So for example, let's look at example 2. This is n squared minus 3 squared. The minus sign is there. We do exponents first. 3 times 3 is 9, and there's the n squared. This one would be 4x. The whole thing is being squared, and y is being squared. It's sum and difference pattern. So 4 times 4 is 16, x squared minus y squared. Okay? All right, so go to the next page for a second. We're going to skip example 3, and I want you to do 4 through 6 right now using the sum and difference pattern. Pause the video and try it out. Okay, so let's see how you did. Number 4 is z squared minus 36, sum and difference pattern. Same thing with this one. Make sure you squared the 4 and the x to make 16x squared minus 9. There's always a minus sign in between sum and difference pattern because exponents come before subtraction. And then number 6 is x squared minus 25y squared. Make sure you squared the 5. All right, let's look back at example 3. You're probably not going to have any questions on the test on example 3. However, it's interesting to kind of look at what they were thinking when they said use special products to find the product of 17 times 23. So what they say is notice that 17 is 3 less than, what's it 3 less than? 20, while 23 is 3 more than 20. So another way that I could have written this is instead of 17, I could use the same as 20 minus 3. 20 minus 3 is 17. And instead of 23, I could have said that's the same as 20 plus 3. Well, what do I have? I have the sum and difference pattern. So I'm going to use my shortcut, which is 20 squared minus 3 squared, otherwise known as 400 minus 9. And what is 400 minus 9? 391. And when we enter 17 times 23 on our calculator, we get 391. So I didn't actually need to use a calculator. I was able to do all this in my head using sum and difference pattern. All right, the same idea would work for number 7 here. Describe how you can use special products to find 39 squared. Well, 39 is the same as 40 minus 1, and I can square that. Well, is that sum and difference pattern? No, that's a perfect square trinomial. That's back to the square of a binomial pattern, okay? So that would be the same as 40 squared minus 2ab, so minus 2, or we'll say plus a negative. We'll say plus for now because I'll make it a negative one. So 2 times a, which is 40, times b, there's my negative sign now, plus b squared, which is negative 1, it's going to be squared. So 40 squared is 1600, 4 times 4 is 16, add your 2 zeros, plus a negative 80, we're multiplying there, plus 1. And when I enter that in my calculator, I get 1,521, and that's the same as doing 39 squared on my calculator, okay? So I would use the square of a binomial pattern to help me with that one. All right, the last thing we need to look at is example 4, and we're going to get into science. So you may have discussed this in genetics earlier. So we are talking about eye color, okay? And an offspring's eye color is determined by a combination of 2 genes. One is inherited from each parent. Each parent has 2 color genes, and the offspring have an equal chance of inheriting either one. So the gene capital B is for brown eyes, and the gene lowercase b is for blue eyes. I know they had to, give us all B's here, right? So you need to remember capital B is brown, lowercase b is blue. Okay? Any gene combination with a capital B in it, if there's any capital B, you're going to get brown eyes. So suppose each parent has the same gene combination. They have a capital B and a lowercase b, okay, brown and blue. So what we're going to do here is we're going to use a Punnett square. So this was our 4 square we were using before, but it's actually in science called a Punnett square. And we're going to show the possible gene combinations of the offspring resulting from there. So here's one parent with a capital B, lowercase b, and here's the other parent, capital B, lowercase b. And then when you multiply them out, you can see that this is a double B, so what will that result in? Brown. Capital B in this one, brown. Capital B in this one, brown. 2 lowercase b's, that's the only one that will have blue eyes there. Okay, so this guy was the blue eyes one, the rest were brown. So the question says, what percent of the possible gene combinations of the offspring results in blue eyes? Well, what percent? It's 1 out of 4. 1 out of 4 is what percent? 25%. Okay? So to fill in the step 1 solution, notice that the Punnett square shows that 1 out of 4, or 25%, of the possible gene combinations result in blue eyes. Then the next question says, show how you could use a polynomial to model the possible gene combinations of the offspring. Okay? So what we have here basically is this is half of the information going in here, 50% of the genes, right? And this is the other 50% of the genes. Okay? So we can't use 50% in our equation. We need to use 0.5. So half of the genes are a capital B for brown. So a 0.5 are brown going in, and half are the lowercase, the blue gene going in. And there are 2 parents, so I'm squaring that. Okay? I can't use 50%, I need to use 0.5. So we had a B and a lowercase b, so there's my half was a brown, half was a blue. 2 parents means to square it. Okay? So the possible gene, oops, this is where my squared goes right here. That was supposed to be 1 person. There's where I square it. Okay, so notice that this product also represents the area of a Punnett square. Okay, so what I'm going to do is I'm going to take that 0.5 brown plus my 0.5 blue squared, and I'm going to use my shortcut to find out the answer. So it's a binomial, right? So it's 0.5 capital B squared plus 2A, the A term is the first one, 0.5 brown, times B, 0.5 blue, plus B squared, 0.5 blue squared. And then we'll simplify that. So, 0.5 times 0.5 is 0.25, and it's B squared, capital B. The next one, 2 times 0.5 times 0.5 is 0.05, B, capital B, and lowercase b. And then we have 0.025 lowercase b squared. Okay? The coefficients show that 25% of the gene combinations result in blue. How does it show that? Which one was the blue? Capital B, capital B. Oop, here it is. 0.25 is what percent? 25%. Okay? So this step 2 is bonus work, but you could be expected to know the step 1 that we did. All right? So last question here. Look back at example 4. What percent of the possible gene combinations of offspring results in brown eyes? Well, if 25% were blue, what percent is brown? 75%. All right, those are your notes for 9-3. Continue on to your next step. Great job.